Hi kids, this is Teacher May, your teacher for today. Please don't forget to like, share, subscribe, and hit the notification bell for the latest videos. Using multiples of a given number up to 100 in determining equivalent fractions. Since we already discussed the multiples of given numbers, let us use what we have learned from this lesson to continue learning about equivalent fractions. It can be recalled that before the lesson on multiples, we discussed what equivalent fractions are and how to determine if the given fractions are equivalent using models. Look at these fractions. The first one is 1/2. The second one is 2/4. The third one is 3/6. The fourth one is 4/8. And the last one is 5/10. The models provide clear illustrations of equivalent fractions. Although with different numerators and denominators, the fractions have the same amount or quantity of shaded parts. Given the same examples, let us identify if fractions are equivalent without using models, but by applying our lesson on multiples. 1/2 times 2/2. In multiplying fraction, multiply first the numerator. 1 times 2 is equal to 2. Then multiply the denominator. 2 times 2 is equal to 4. 1/2 times 3/3. First multiply 1 and 3. 1 times 3 is equal to 3. 2 times 3 is equal to 6. The answer is 3/6. 1/2 times 4/4. First multiply the numerator 1 and 4. 1 times 4 is 4. And then multiply the denominator. 2 times 4 is 8. The answer is 4/8. 1/2 times 5/5. First multiply 1 and 5. 1 times 5 is equal to 5. 2 times 5 is equal to 10. The answer is 5/10. What have you noticed with a given set of fractions? When you multiply both numerator and denominator by the same number, you can generate fractions equivalent to the given fraction. When you multiply both numerator and denominator by the same number, you are as if multiplying them by a fraction equal to 1. Example, 2/2 is equal to 1, 3/3 is equal to 1, 4/4 is equal to 1, and 5/5 is equal to 1. Remember that any number multiplied by 1 is the number itself. In our discussion of multiples, it was highlighted that multiples of given numbers extend infinitely. Ergo, following this principle, we can generate an infinite number of equivalent fractions with any given fraction. Give the first 5 equivalent fractions of the following. Solutions: 3/4 times 2/2 is equal to 6/8. 3/4 times 3/3 is equal to 9/12. 3/4 times 4/4 is equal to 12/16. 3/4 times 5/5 is equal to 15/20. 3/4 times 6/6 is equal to 18/24. Therefore, 3/4 is equal to 6/8. 6/8 is equal to 9/12. 9/12 is equal to 12/16. 12/16 is equal to 15/20. 15/20 is equal to 18/24. Letter B, 5/7 times 2/2 is equal to 10/14. 5/7 times 3/3 is equal to 15/21. 5/7 times 4/4 is equal to 20/28. 5/7 times 5/5 is equal to 25/35. 5/7 times 6/6 is equal to 30/42. Therefore, 5/7 is equal to 10/14. 10/14 is equal to 15/21. 15/21 is equal to 20/28. 20/28 is equal to 25/35. 25/35 is equal to 30/42. Letter C, 1/8 times 2/2 is equal to 2/16. 1/8 times 3/3 is equal to 3/24. 1/8 times 4/4 is equal to 4/32. 1/8 times 5/5 is equal to 5/48. 1/8 times 6/6 is equal to 6/48. Therefore, 1/8 is equal to 2/16. 2/16 is equal to 3/24. 3/24 is equal to 4/32. 4/32 is equal to 5/48. 5/48 is equal to 6/48. Letter D, 4/9 times 2/2 is equal to 8/18. 4/9 times 3/3 is equal to 12/27. 4/9 times 4/4 is equal to 16/36. 4/9 times 5/5 is equal to 20/45. 4/9 times 6/6 is equal to 24/54. Therefore, 4/9 is equal to 8/18. 8/18 is equal to 12/27. 12/27 is equal to 16/36. 16/36 is equal to 20/45. And 20/45 is equal to 24/54. Letter E, 7/6 times 2/2 is equal to 14/12. 7/6 times 3/3 is equal to 21/18. 7/6 times 4/4 is equal to 28/24. 7/6 times 5/5 is equal to 35/38. 7/6 times 6/6 is equal to 42/36. Therefore, 7/6 is equal to 14/12. 14/12 is equal to 21/18. 21/18 is equal to 28/24. 28/24 is equal to 35/38. And 35/38 is equal to 42/36. Again, how do we generate fractions equivalent to a given fraction? To generate equivalent fractions, multiply both the numerator and denominator of a given fraction by the same number. Equivalent or not equivalent. Aside from generating equivalent fractions, we can also determine or check if the given fractions are equivalent without choosing models or visual representations. Find the missing number to make the fractions equivalent. To find the missing number, use cross multiplication. Multiply 2 and 15. 2 times 15 is equal to 30. And then, divide 30 by the denominator 5. 30 divided by 5 is equal to 6. Therefore, 2/5 is equal to 6/15. Next is letter B. Again, to find the missing number, use cross multiplication. 2 times 15 is equal to 30, and then divide 30 by 3. 30 divided by 3 is equal to 10. Therefore, 2/5 is equal to 15/10. To check if these fractions are equivalent, we can use cross multiplication. 2 times 15 is equal to 30. 5 times 6 is equal to 30. They have the same answer, so they are equivalent fractions. 3 times 10 is equal to 30. 2 times 15 is equal to 30. Again, they have the same number, so they are equivalent fractions. What have you noticed? After doing cross multiplication, the products are equal, the fractions are equivalent. Check if the pair of fractions are equivalent. Again, we can use cross multiplication to determine or check if fractions are equivalent. Based on the examples, how to perform cross multiplication in order to determine if the fractions are equivalent. Multiply the numerator of the first fraction by the denominator of the second fraction. Then, multiply the denominator of the first fraction by the numerator of the second fraction. If the products are the same, the fractions are equivalent. Now, let's have an activity. Answer the following. Give any 5 fractions equivalent to the given fraction. Limit your answer to fractions whose numerator and denominator are up to 100 only. Using cross multiplication, check whether the fractions are equivalent or not. Write your answer in the blank after the given. Factoring a given number up to 100. You can use the multiplication table to help discover the factors of different numbers. I would like you to circle all the numbers 20 in the multiplication table. What numbers are multiplied to get the product 20? Answer: 20 and 1, 5 and 4, 10 and 2. What do you call the numbers being multiplied to get the product? The numbers being multiplied to get the product are called factors. Look at these examples. 20 times 1 is equal to 20. 20 and 1 are the factors. 20 is the product. 10 times 2 is equal to 20. 10 and 2 are the factors, and the answer 20 is the product. 5 times 4 is equal to 20. 5 and 4 are the factors, and the answer 20 is the product. The factors of 20 are 20, 10, 5, 4, 2, and 1. Since the factors of 20 are 20, 10, 5, 4, 2, and 1, this means that when you divide 20 by each factor, the quotient will not have a remainder. Hence, a factor of a given number will divide that given number precisely without a remainder. Factor the given numbers. Letter A, 6. 6 times 1 is equal to 6. 3 times 2 is equal to 6. The factors of 6 are 1, 2, 3, and 6. Letter B, 8. 8 times 1 is equal to 8. 4 times 2 is equal to 8. The factors of 8 are 1, 2, 4, and 8. What are the common factors of 6 and 8? Factors of 6: 1, 2, 3, and 6. Factors of 8: 1, 2, 4, and 8. Common factors of 6 and 8 are 1 and 2. Which of the common factors of 6 and 8 is the greatest? The answer is 2. What are the common factors of 12 and 18? Letter A, 12. 12 times 1 is equal to 12. 6 times 2 is equal to 12. 4 times 3 is equal to 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. Letter B, 18. 18 times 1 is equal to 18. 9 times 2 is equal to 18. 6 times 3 is equal to 18. The factors of 18 are 1, 2, 3, 6, 9, and 18. What are the common factors of 12 and 18? Factors of 12: 1, 2, 3, 4, 6, and 12. Factors of 18: 1, 2, 3, 6, 9, and 18. Common factors of 12 and 18: 1, 2, 3, and 6. Which of the common factors of 12 and 18 is the greatest? The answer is 6. What are the common factors of 24, 30, and 36? Letter C, 24. 24 times 1 is equal to 24. 12 times 2 is equal to 24. 8 times 3 is equal to 24. 6 times 4 is equal to 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Letter D, 30. 30 times 1 is equal to 30. 15 times 2 is equal to 30. 10 times 3 is equal to 30. 5 times 6 is equal to 30. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Letter E, 36. 36 times 1 is equal to 36. 18 times 2 is equal to 36. 12 times 3 is equal to 36. 9 times 4 is equal to 36. And 6 times 6 is equal to 36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. What are the common factors of 24, 30, and 36? Factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. Factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Common factors of 24, 30, and 36. 1, 2, 3, and 6. Which of the factors of 24, 30, 36 is the greatest? The answer is 6. Remember, the greatest common factor or GCF is the largest positive integer that divides two or more numbers without leaving a remainder. In simpler terms, it is the biggest number that is a factor of all the numbers in a given set. For example, the GCF of 12 and 16 is 4 because 4 is the largest number that divide both 12 and 16 evenly. Given these examples, what have you observed with the factors of each given number? Factors of each given number consistently include the number itself and 1. What factors are common to all the given numbers? 1 is a common factor of 2 or more numbers. Based on the examples, how do we get the common factors of given numbers? List the factors of a given number. Identify the common factors from the list. 1 as the common factor. What are the common factors of 8 and 15? Factors of 8, 1, 2, 4, and 8. Factors of 15, 1, 3, 5, and 15. Common factors of 8 and 15 is 1. Let's have an activity. List the factors of each of the given numbers, then identify the common factors of each set.